No. Alright, so today we're going to be completing the square, okay? So we're still talking about quadratic equations and how to solve them. Alright, so before Friday when we talked about imaginary numbers, we talked about graphing, factoring, and square roots, okay? We use those three methods to solve quadratic equations. Alright, today we're using another method, and that method is completing the square, okay? Completing the square. And this method is very handy when we want to convert standard form to vertex form, okay? When we want to convert standard form to vertex form. Can you guys stop staring at me? I cannot focus, okay? That's when this method is very beneficial, okay? Otherwise, the one we learn tomorrow and the ones we've already talked about, those are the ones we'll typically use, okay? So to understand how to complete the square, we first have to understand what trinomial squares are, alright? I'm going to talk about perfect squares because we already know what perfect squares are. I know you're perf. I'm perf too. Okay, so perfect squares, such as 64, we know this is a perfect square because that's a perfect 8 times 8. Okay, 8 times 8. So we know that this is 8 squared. Okay, and because it's a number times itself, we know it's a perfect square. All right. So trinomial squares, what we're going to be focusing on today, see, Mrs. Kingston showed me this really cool way to write. Have to write kind of like this so that y'all can see. See? She's like a master. You guys don't understand. So no. Because if I write like this, I literally was covering up everything. And so now, it's just those little things, okay? The little things that count. So now, alright, you guys always get me off track, okay? So now, we're going to talk about trinomial squares, alright? So this right here is a trinomial square, okay? This right here is a trinomial square, alright? This is the binomial x minus 8 squared. Okay? Can you make the connection? This is, you get a trinomial squared when you have a binomial multiplied by itself. Okay? So this is x minus 8 times x minus 8. This here is a trinomial squared. Alright? So, if you do not know, if you cannot see that it's x minus 8 squared right off the bat, there are two things that make a trinomial square. The first one, A and C are perfect squares. Okay, A and C are perfect squares. And B is 2 times plus or minus the square root of C. Okay? So if we look here, A and C, well, A is 1 and x times x is x squared. And C is 8 times 8, okay? Or negative 8 times negative 8. And then our B is 2 times plus or minus square root of C. Our B is 2 times negative 8. 2 times negative 8 is negative 16. So this here, if we didn't know it, if I didn't tell you guys, you'd be able to just look here, look at your A and C, and tell that this is a trinomial square. Alright? So today, that's kind of like the base. That's what we're building everything on. Alright? I kind of said that, I don't know if I mentioned it, but the main reason we're going to learn completing the square is to write standard form as vertex form, to convert these two, okay? But before we do that, we're going to learn how to solve these equations, okay? So we want to be able to make a perfect square trinomial. Okay, that's a E, not a O. We want to make a perfect square trinomial. So if we were given x squared plus 8x, alright, and we want to make this a trinomial square, okay, we have to add c. Alright, we have to add c. We'll just go ahead. C will always be b over 2 squared. Okay? C will always be b over 2 squared. And when we find c, we'll be able to write our trinomial as x plus b over 2 squared. We'll write it as a binomial squared. Okay? So for example, if we wanted to make this a perfect square trinomial, we would add c. What is c going to be? That's not a rhetorical question. Yeah, 16. Okay, it's 16. Because our b is 8. So b divided by 2 is 4. And 4 squared is 16. So we're going to add 16. Okay? And once we add our c, we can write this trinomial as a binomial squared. So that will become x plus what? What's b over 2? 4. X plus 4 squared. Okay? X plus 4 squared. If you look at your vertex form, okay, this resembles the x minus h squared. Okay? This resembles the x minus h squared. So that's why we use this to convert the two forms. And we'll go over that at the end. Okay? So what we did here was we just made this a perfect square trinomial. Alright? So let's say we have, let's do this one, x squared minus 9x. Alright? And we want to make this one a perfect square trinomial. What are we going to add? What's our c? Excuse me? Okay, so 9 divided by 2 is going to be a fraction or a decimal. It's not going to be a nice number like 8, okay, since 9 is odd. So when that happens, what I always do is, if it's not a nice number, I write my b over 2 here, okay. So our b is negative 9. So my b over 2 is negative 9 over 2. Alright. And my b over 2 squared is going to be, you know, b squared over 2 squared. Okay. So negative 9 squared is 81. And 2 squared is 4. Alright. Anytime we get fractions, we want to leave them as fractions. Because fractions are easier to multiply, divide, add, and subtract. They're easier than decimals. And you're guaranteed the exact answer. Okay. So here we're going to add this c. Okay, this is your c. So we're going to add c. Alright, so we're going to add 81 over 4. Okay. Now that we've made this a trinomial square, how can we rewrite it? X plus, yeah. So what would that be? Excuse me? I can't hear you. Excuse me, what did you say? Okay. That right there is a common mistake that I used to make all the time. Alright? What it's going to be is x minus 9 over 2. Okay? 9 over 2 squared. It's here. It's the b over 2. Alright? I'm kind of glad you did that because I used to do it all the time. So a lot of times once we complete the square, we want to put this inside our binomial. Okay? This is b over 2 squared. What we need inside the binomial is just b over 2. Okay, and we said b over 2 is negative 9 over 2. And that's another reason why I like to write my b over 2 to the side and my b over 2 squared. So I can just plug this in. Okay, so that right there is making a perfect square. Alright, we need to be able to do this because that's how we complete the square. Okay, that's how we complete the square and solve quadratic equations, and also how we convert standard form to vertex form. Alright, so now we're going to solve a few. Okay, I feel like Dawson is watching me write and is critiquing every little stroke. I didn't hear you. I have selective hearing. I'm like a master at selective hearing. Oh, you're so funny. So funny. Okay, so here we go. If we're given this equation, alright, x squared plus 8x minus 5, and this equals 0, alright? We're going to solve this equation. We're going to find the solutions, find the zeros, find the roots, find the x-intercepts, all the above. Okay, always the same thing. Alright, so the first thing, is this a trinomial square? No, because negative 5 is not a perfect square. Okay, so what we want to do is we want to, anytime it's not a trinomial square, we want to move that 5 over. Okay, so we want to add 5 to both sides. Okay, so now we have x squared, and where we move that 5, we want to leave a blank space. Okay, we want to leave a blank space. So now we have x squared plus 8x plus blank equals plus 5. So, using our prior knowledge, okay, what we just covered, what do you think we're going to do here? We're going to put our c, yes, we're going to put 16. We're going to complete the square, okay? We're going to complete the trinomial square, alright? So, our b is 8, well b over 2 is 4, and 4 squared is 16, okay? So that's our c. Now, what we do to one side, we have to do to the other, okay? What we do to one side, we have to do to the other. Why do we have to do that? Balance. Very good. In life, you have to maintain balance. Okay? Alright, so if you think this is a balance beam, we have to keep it balanced. Okay, so what you add to one side or subtract to one side, you have to do to the other. Okay, so what's 5 plus 16? 21. Okay, how can we rewrite this? Close. I mean, you know, it's not. We want to write it as binomial squared. Yes. So this is going to be x plus 4 squared. X plus 4 and all of that squared. Okay, and we know it's 4 because what goes inside the binomial is just b over 2. Okay, 8 over 2 is just 4. So now that was the completing the square part. Okay, if we're asked to solve by completing the square, we just completed the square. Now we just solve using one of the methods that we've used before. Okay, when did we factor? What did we have that told us we needed a factor? Started with try, ended with nomial. Yeah, okay. So it's trinomial. When we have trinomial, that's when we factor. Okay, do we have 3 different terms? No, we don't. Okay, so what we want to do is we want to use square roots. Okay, so how do we get rid of this power? Square root it. Okay, we want to begin to solve for x, so we want to square root it. So if I square root this side, okay, what happens when I square root the right side? What do I need to put? blank or blank the square root of 21. Yeah, there you go. Plus or minus the square root of 21. Okay? Anytime we take the square root, we have to remember to put plus or minus. So now these undo each other. They're inverse operations. So we just have x plus 4 equals plus or minus square root of 21. Okay? So now, is x by itself yet? No. What should we do? Very good. Subtract 4. Okay? And when we subtract 4, we want to always put the radical second. Okay? So it'll be negative 4 plus or minus the square root of 21. Alright? Are we done? What do we have to do? Yeah, we want to see if this is simplified. Okay? So you can do this in your head. You can think of the factors of 21 and see if any of them are perfect squares and take it out. But if you're ever uncomfortable with that, factor tree always works. Alright? So if we do the factor tree over here to the side of scratch work, okay, what are the factors of 21? 3 and 7. Can we break the 7 up to 3? Do we have a pair? No, so we just leave it. Okay? So this is our answer. Okay? That is our answer. Alright? So now, alright, let's do one more example for just solving equations. And then we have equals negative 42. Okay, so we have 6x times x plus 2 equals negative 42. Is this a quadratic equation? Yes, but it doesn't. It's kind of hidden. It's a ninja. Okay, kind of like Bailey. All right. So what can we do to make this look like a quadratic equation? Distribute. So we'll get 6x squared plus 12x equals negative 42. Okay? All we did was distribute the 6x. So anytime that we're using completing the square method, we have to make sure that our a is positive 1. Okay? If it's not positive 1, we have to make it positive 1. Okay? So how can we make our a positive 1? Yeah, divide by 6. And it just so happens that all our coefficients have a factor of 6. Okay? So this is x squared plus 2x equals negative 7. Alright? Now, we've done that. We see that we have a leading coefficient of 1, an a term of positive 1. So if we move that 7 over, okay, don't do it, but just think about it. If you move that 7 over, would we have a trinomial square? No, okay. So that is already moved to the side, okay, that's already separated. So we want to leave that space. We want to find our c, okay. So we'll have x squared plus 2x plus blank plus whatever our c is going to be equals negative 7. So we want to complete the square for the left side. Alright. What will our c be? 1. Okay, because it's b over 2 squared. So that's 2 over 2, which is 1, and then 1 squared is 1. Alright, and what we add to one side, we have to add to the other. Alright. So how can we rewrite the left side? X plus 1 squared. Okay. You're saying it so sad. I was just making sure you're okay. X plus 1. Okay. So it's x plus 1 squared. Alright. Now, we've completed the square. We've rewritten it. So we want to use the other methods. And there's not 3 terms. Okay. So we don't want to factor. So we want to use square roots. Alright. So how do we get rid of that power? Square root it. Okay. I square root this. What will I be left with? X plus 1 Then when I square root this side, what will it look like? Yeah, plus or minus the square root of negative 6. Very good. So before we talked Friday, okay, before we talked Friday, when we had a negative under the radical, we said no real solutions. Alright? Well, Friday we learned about the amazing imaginary numbers. Okay? So anytime we have that negative under the radical, what can we do, Dawson? Say it loud. You can take out the 9. You can take the square root of negative 1. Okay? We know the square root of negative 1 is I. Okay? So we can rewrite this as x plus 1 equals plus or minus I times the square root of 6. So all we did was, this is negative 6 is like negative 1 times 6. We took the square root of negative 1. Well, the square root of negative 1 is I. Okay? So do we have our answer? No. What do we have to do? Subtract 1. We want to isolate x. Okay? And we write the 1 first. We have x equals negative 1 plus or minus I times the square root of 6. And that, oh, I messed up. Oh, y'all can't even see it. Wow. That's your answer, just not as sloppy. Because the I goes with the square root. It's I times the square root of 6. Okay? So that's solving. That's how we solve using the quadratic. Sorry. That's how we solve using completing the square. Okay? Alright, the last thing. Okay? That was just like, you know, your soup and salad and your breadsticks. Okay? Maybe like a triple dipper from Chili's. You know? That was just the appetizers. Now we're ready for the the main course. So like your steak, your crab legs, you know, just the usual lobster. What do you guys normally eat for dinner? Okay. So so we want to go from standard form, and this is pretty easy, to vertex form, okay? And we want to be able to find the vertex. How do we, when we have vertex form, what do we know the vertex to be? HK, okay? Your vertex is going to be HK, alright? So now, let's say we have the equation y equals x squared plus 6x plus 4. And we want this in vertex form, and we also want to know what the vertex is, okay? First thing to do is look to see whether or not this is a trinomial square. It is? Why not, Philip? Is a 4 perfect square? Yes. So is this a trinomial square? No. The 6. I tricked you guys. Okay. So we know that A and C have to be perfect squares. Okay. We have x times x, 2 times 2. But then B is 2 times plus or minus the square root of C. So the square root of C is 2. Is 6, 2 times 2? No. Okay? So what we want to do is we want to make a perfect trinomial. Alright? Not a perfect trinomial. A trinomial square. Alright? So to do that, we isolate, or we put in parentheses, the first 2 terms. Okay? And then we leave a space like we've been doing. And then the 4 is just all by itself. Okay? He's a loner. But he's a happy loner. He's still happy. Okay. And if you look at your notes, oh yeah. If you look at your notes, this is kind of our K. All right. If you look at the vertex form, this is kind of our K. So what we're going to do is we're going to complete the square here. So what is our c going to be? 9. Okay, it's b over 2 squared. Well, 6 over 2 is 3, and 3 squared is 9. So how, before I do that, what do we need to do to the other side? Add. No. We want to keep it on the same side because we're not solving for x here. We're just converting standard form into vertex form. So if you like a vertex form, you have the plus k at the end. So that's kind of what this is becoming, the plus k. Alright, so we added 9 here, so we have to add 9 to the left side. And now how can we rewrite what's inside the parentheses? Yes, x plus 3 squared. Okay? And that right there is the middle part of your vertex form. Okay? So now to get it as an equation, what's the last step? Subtract 9. Okay? Because when we have an equation, we have it as y equals. So we want to subtract 9. And then your vertex form, your final form is going to be x plus 3 squared minus 5. I tricked you guys. Yeah. Okay. So if we look at the vertex form, alright, that is a times x minus h squared plus k. That's what we have here. Our a is 1. Okay. What would our vertex be? Very good. -3, -5. Good job, Philip. Okay. The way what you have to remember is that the vertex form is x minus h. This is x plus h. So you can either think of this in your head or you can always rewrite it. Okay. I used to have to rewrite it at first, but it'll be x minus a -3 squared minus 5. Okay. Because x minus -3, that's the same as x plus 3. Okay, so your h is actually -3. It's not 3. Okay, does that make sense? Because the vertex form, in order to determine the vertex, we have to have it as a times x minus h. This was plus h. So that's really subtracting a -3. Alright? So in your answer, you can just leave it here, okay? You can that can be your vertex form. You just have to make sure you get the vertex right. Okay? Alright. Well, that is completing the square, okay? And again, the most important part completing the square is be able to convert standard form to vertex form. Alright? That's the most important part. Alright, you'll have to be able to solve, okay, but there are other methods that usually work a little bit nicer than solving, okay, just such as factoring or the square root or what we're going to cover tomorrow. Alright, well, you guys have a good day.